In this question, we're combining 42 unit cubes to create a larger cuboid. And if we let the dimensions be x, y and z, where x and y are the dimensions of the base, we can write down that 2x plus 2y is equal to 16, which we can simplify to be x plus y is 8. We also know that the volume of the bigger cuboid is 42. So that means that x multiplied by y multiplied by z is equal to 42. Essentially, this problem now boils down to finding a factor triple of the number 42, where two of those factors sum to 8. Okay, so finding all the factor triples of 42 is something we need to do very carefully. We need to be sure that we don't miss any. Now, if I have three whole numbers that multiply together to give 42, the smallest of these should be less than or equal to the cube root of 42. You might like to take a moment just to think about why that's true. Now, 42 is between 3 cubed, which is 27, and 4 cubed, which is 64. And that means that the cube root of 42 is between 3 and 4. And that means that when we list our factor triples of 42, the smallest factor has to be one of 1, 2, or 3. We're now going to list all the factor triples of 42. If the smallest factor in the factor triple is 1, the remaining two factors need to multiply to give 42. So we need to look at the factor pairs of 42. If the next number in the factor triple is also 1, this means the next and final number in the triple has to be 42. So we have one factor triple of 42. If we stick with the smallest factor being 1, and we allow the next one to go to 2, this means the final number needs to be 21. And again, if we stick with the smallest factor being 1, and we say that the next factor of 42 is 3, the final factor would need to be 14. And we can have one final triple where the smallest factor is 1, and the next factor would be 6, and the final factor would be 7. And if we look at these pairs here, 1 and 42, 2 and 21, 3 and 14, and 6 and 7, these are the only factor pairs of 42. So these are all of the factor triples where the smallest factor is 1. We'll now move on to the case where the smallest factor in the triple is 2. So if the first number in the triple is 2, 42 divided by 2 is 21. So we now want a factor pair of 21 where both factors are at least 2. So we can have 3 and 7. And in fact, 3 and 7 are going to be the only factor pair of 21 where that's true. Considering the final case, where the smallest factor in the factor triple is 3, 42 divided by 3 is 14. So we're now looking for a factor pair of 14 where both factors are at least 3. And there is no such factor pair. So in this case, we have no possibilities. Now, finding the factor triples in this way means we can be certain we have found them all and there are none missing. Now, if we look at these possibilities, what we're looking for is a factor triple where two of the factors, any two of the factors, sum to 8. And if we look through this short list, we can see that in fact there is only one factor triple where this does occur. And we want to take this triple here. So this one's no good. No two of the factors sum to 8. This one's no good. This one's no good. And that leaves us our final factor triple, which does work because 1 adds 7 is 8. And that means that the height of our cuboid is 6. And that is our final answer.